Hello, my name is Mason Chirpin, and today we'll be discussing understanding intramolecule and intermolecule forces of material properties. And today I'll be discussing how properties and applications of present materials are influenced by inter and intramolecules, or forces, if you will. The exploration is essential for understanding both everyday materials and applications in science and technology that we use today. Again, my focus question is, how might the properties of applications be in present days be influenced by intra and intermolecule forces? To begin, let's clarify the two key concepts involved in our discussion. One, intramolecules are forces that are strong molecules that hold up atoms together with a molecule. This includes covalent bonds and ionic bonds. Covalent bonds is where atoms share electrons to achieve sustainability. Ionic bonds, sometimes I call it bonds, but compounds, but yeah, you know what I mean, are when atoms transfer electrons to another, creating charged ions that attract each other, if you will. These forces are crucial for intermolecule and determine how molecules will interact with one another. Now, intramolecules are forces that are weaker forces that occur between different molecules. This can be categorized as hydrogen bonds, dipole-dipole interactions, and Van der forces. Hydrogen bonds, if you will, are stronger than intermolecular forces. These occur when hydrogen is bonded to electronegative atoms like oxygen and nitrogen, significantly interacting and impacting properties such as boiling points of interactions. Now, the dipole-dipole interactions, these occur when polar molecules, due to the interaction and attraction of positive and negative ends. Now, the Van der forces, they are the weakest interactions arising from temporary shifts in electron density among molecules. Now, the role of intermolecular forces. Understanding the intermolecular forces is how they influence physical properties of substances. For instance, the high boiling point water can be attributed to hydrogen bonding. In contrast, substances with weaker intermolecular forces exhibit lower boiling points. This understanding allows us to predict materials' behaviors in various conditions, such as why oil and water do not mix. Which is an excellent example of dipole interactions at work and in science, also in everyday, are like, for example, like we mix something up, and we're like, hey, why isn't oil and water mixing? Well, hey, we know now that's a dipole interaction of science. Now, in conclusion, the understanding of intermolecule and intermolecule forces is very, very crucial, not only for grasping but for science behind materials, but also for applying knowledge in our practical settings and our everyday world around us. By these forces, we can understand material specific applications, like leading achievements in technology and material science and our future that goes on today. Thank you for watching, and